Hello, today's video is going to look at ionic bonding. So there are three types of bonding that we're going to look at in this particular section of the course: ionic, covalent and metallic. And ionic's the first of these. You'll need, or would be useful, specifically need, I'll keep on referring back to it anyway, it's a periodic table help. There's this version of the periodic table I've included a link to at the bottom, so you just go grab a copy if you want. I will keep on referring back to it, so it's not essential. So we looked at electron structure in a previous lesson, and we saw that for the first 20 atoms, any of our elements, we could draw their structure with these shells. So I'm just going to draw a quick version now. I'll just put this atom's electron structure on the board, and just as a quick recap, if you wanted to, you'd see quickly which element do you think this is. And the clue here is that it's got one electron in its outer shell, so it's going to be a group 1, and it's also got 11 electrons in total. And it's an atom. So we're going to have a look on our periodic table. We know it's going to be in group 1, and I've drawn here sodium. The proton number should, in this, equal the number of electrons because it's an atom. So what we can say about sodium is that at the moment it's not as stable as it can be. Sodium has got one electron in its outer shell, and actually that one electron's quite reactive. It gives it some chemical properties. So in order for it to get stable, it'd want to lose this one electron, and that will want to go. So it does this quite often. And sodium, when it reacts with something else to make an ionic bond, loses that electron from its outer shell. It goes. So I'm going to say that's gone over here. Now that means it's still got the initial 11 protons. We saw its atomic number was 11. Let's move that up a bit. It's now only got 10 electrons. So it's developed a positive charge. It's got one more positive charge than it has negatives. So we're going to put up here that it's a positive charge. Zoomed in just a bit too much on this. So because it's got this positive charge, the positive charge goes around the whole atom. And we need to display that by putting it in brackets. And it's now no longer an atom, it's an ion. And when these ions attract to each other, so when we find a negative one and it attracts to a positive, that is an ionic bond. So sodium as a metal will generally, nearly always form positive ions, and generally positive with just a single positive charge. So I could have put +1 up here. If we have a look at another example, there we go. This time I'm going to draw this one with dots instead of crosses to represent my electrons, and I'll come to Y in a little set when we start to put it all together. So there I've drawn an atom, and it's got, well, an electron structure of an atom, and it's got 7 electrons in its outer shell. So we know this is going to be in group 7. It's also got 9 in total. So because it's an atom, we can see this is going to be fluorine. And I've drawn here fluorine. Now fluorine is unstable as well. Well, it's very reactive. It's not got this full outer shell, so it means it wants to react to other things. Unlike sodium, in order to get a full outer shell, it's easier for fluorine to gain electrons. So remember that sodium electron, I'll draw this in red, that we had earlier that got lost in the sodium, that is going to join on to the fluorine and go in. So it's going to gain electrons to get a full outer shell. And generally, we'll come to this fluorine will then become -1. This is because it's still only got 9 protons. We haven't changed the number of protons at all. but it now has gained an extra electron. So because it's gained that extra electron, it's slightly more negative, and it's one more negative. So one more negative charge, so therefore -1 in fluorine. So we can put this together to show an ionic bond. Oh, in fact, first of all, I'll just go through our sodium that's going to lose electrons. This is a metal. Metals give away their electrons. And fluorine, which gains an electron, that's a non-metal. And so if we look at the periodic table, we've got our metal here, sodium, which has only got one electron in its outer shell. It's in group 1. Easiest way for that to get a full outer shell is just to give electrons away. Same with group 2. 2 electrons in the outer shell, easy for them to give away than to gain 6 electrons to get a full outer shell the other way. As you get further across though, so boron's still easier to give it away, bit of a weird one. When you get into the carbons, nitrogens, oxygens, fluorines, they're going to gain electrons generally. Carbon doesn't really ionically bond. We'll come to how carbon bonds later, but the nitrogen, the oxygen, the fluorine, group 5, group 6, group 7, they're all easy to gain electrons. And we call these non-metals. So the right-hand side of the periodic table, generally, if you were to draw a line, a diagonal line down here, everything to the right-hand side of that, all this area, there are non-metals. Everything else, most of the periodic table, are metals, and they give away electrons when they form ionic bonds. So we have a look at this. We've got our sodium here, our fluorine here. And what happens is sodium needs to lose an electron, fluorine needs to gain an electron. So this electron is going to go across and over to the fluorine. So I'm going to draw this slightly differently now. Because sodium's lost that electron in its outer shell, it now has a full outer shell of 8 electrons. And it's lost an electron, so it's +1. Fluorine over here had 7 to begin with, 9 in total, 7 in its outer shell. It's gained the one from sodium, so that goes there. Put it in brackets to show it's -1. The brackets are probably the most forgotten thing by students. Put the brackets around to show it's the whole atom has become an ion. The negative or positive charge is around the whole of what is now an ion. So this positive charge attracts the negative charge. These two go across, and that gives a nice balanced formula. Then we can put down that this is 1 sodium bonded to 1 fluorine, which is now, when fluorine becomes an ion, we start to call it fluoride. Stuff you see in the toothpaste is probably the most common way you've heard of fluorine. So that is our sodium fluoride, and that is a group 1 bonding, ionically bonding with a group 7. So it's nice and simple. This just gives 1 electron to the other. Now I've used what's known as a dot cross diagram to show this. So the initial sodium electrons are all drawn as crosses, and the initial fluorine electrons are all drawn as dots. And that way we can see that 1 electron has moved across to the fluorine. So we can see this sodium's moved across. We can see that this fluorine's gained an electron. And we can see kind of the difference between the two. We know sodium's given away that electron, fluorine's gained that sodium's electron. Let's look at now a group 2 with a group 6. So there's my group 2. No, it's group 2 because it's got 2 electrons in its outer shell. It's 12 in total. It's an atom, so that'll balance out with protons. So we look at the proton number. We've got 12, so this must be magnesium. Now, magnesium, in order to get a full outer shell, that's going to give 2 electrons away. We then go to group 2 on the other side. Just need to draw all those shells. Get rid of that outer one there. I will show a shortcut in a second how to draw these a bit quicker. This one, 8 electrons in total. We know it's in group 6. It's got 6 in its outer shell. So if I take a periodic table, group 6, 8 in total. This is going to be our oxygen. So magnesium needs to lose 2, oxygen needs to gain 2. So very simply, these 2 electrons are going to come across and go to the oxygen. We can then draw the ionic bond. We'll have our magnesium, which has lost 2 electrons from its outer shell. So now it looks like that. What do you think the charge is going to be on it? Be 2 plus, because it's lost 2 electrons. So it's now still got 12 protons, because we haven't lost any protons, but we've now only got 10 electrons. So the overall charge will be 2 plus. And that is going to bond with our oxygen. And I'm doing the oxygen electrons again as dots this time. So that's its initial 8 electrons, 6 in its outer shell, but it's going to gain 2 from the magnesium. So that now still only has 8 protons, but it's got 10 electrons. So its charge is 2 minus. And again, these charges cancel out. So we've got 2 plus cancelled out by a 2 minus. So that gives us magnesium oxide. For every 1 magnesium, you'll get 1 oxygen. So we get 1 magnesium to 1 oxygen. This just tells us the ratio. We'll now have a look when we put numbers in. So I'm going to stick with magnesium. So 2 electrons out of shell, 12 in total, and we're going to react that this time with fluorine. So 7 in its outer shell, we saw this before, 9 in total. So 1 electron can go to from the magnesium to the fluorine. Put it in there to get our then -1 fluorine. We've then got another electron there, and magnesium still wants to get rid of that electron to be stable. It will still be reactive if it's got an unfilled outer shell. This fluorine's now full though. That can't take any more on. So what happens now, and I've not left myself enough room really to do this, is we won't ever just have 1 fluorine floating around. There'll be billions and trillions of fluorines floating around when they come and collide with each other. So that can then take the second electron. I'll draw this out much neater in just a sec. I'll rub that out. But that's, for every 1 magnesium, can react with 2 fluorines, because it's got 2 electrons and fluorine only needs 1. So I can draw my magnesium a bit bigger. We know that's going to lose 2 electrons to become stable, to form a 2 plus ion. And over here, draw them a bit smaller. Just remember, I'm using dots to represent the fluorine electrons. That's going to gain 1 of the magnesium electrons to become -1. Then down here, because we've got another electron to give away from the magnesium, it can give 2 electrons, it can give it to another fluorine. So we get another -1 there. So when we're writing the formula for this, we have our magnesium and we have our fluorine. But for every 1 magnesium, we now have 2 fluorines. So this is where we start to add numbers. And that gives us MgF2. That is ionic bonding. We show the bond by showing these ions next to each other. I always like to put the negative, if I've got more than 1 ion bonding with another ion, I put them above each other and draw them just a bit smaller. It's up to you how you set them out. I think that's the preferred way to show them. I've included, again, some practice questions to go and do. So there's some worksheets at the bottom. What I will do is show you just a quicker way of drawing out these ions, and one that it often lets you get away with in tests and exams is it says you can just draw that outer shell. So if you're, say, go back to sodium, that has 3 rings, we can get away with sodium. I'll do all 3 to begin with. So doing this every time takes a bit of time, especially then you've got to draw the ion where it loses that electron. So the electron's gone, and that takes a bit of time. It sometimes says just draw the outer shells. And with metals, when they come out shells, you either draw the full one, where you've got all 8 electrons, or you draw the shell where the electron came out of. And you just put an empty shell to show all the electrons have left, and that is now empty, and we assume everything below it is full. The problem with this is now we can't tell what group 1 this is, because you can't see how many shells there are, how many electrons in total. So this could be lithium, sodium, potassium, and so on. So we just put in the centre when we're doing the short one that this is sodium. It's got a full outer shell or a empty where it's lost the electrons, and it's now +1. I've done 2 pluses there. +1. It's lost 1 electron. So that is a quick shorthand way to draw non-metals when they gain electrons, and just to do the outer shells only. We take fluorine that gains an electron, comes the fluoride ion, -1. We can draw that just a bit quicker by doing, this time you have to put the full outer shell because you want to show that it's gained an electron from somewhere else. So you want to see that. And again, in the centre, fluorine, -1. So that saves a bit of time. Obviously, fluorine, you're just missing out on drawing this inner shell, and you put in an F instead. When you get to things like chlorine, that's got another shell again, or bromine you won't really do, but on others, it just saves just a bit of time just to draw the outer shells. That is ionic bonding. Good luck with the questions below. Next video should be covalent bonding.